April 12, 1943, a communications trench somewhere east of Kursk. Soviet Lieutenant Dmitry Volkov pressed himself against the muddy wall as the sound began. Not the whistle of incoming artillery shells he had learned to recognize, not the crack of rifle fire or the rattle of machine guns. This was different. A rising howl that seemed to come from hell itself, a banshee wail that made his stomach clench with primal fear. The first rocket hit 50 meters away, the explosion sending a wall of dirt and fire skyward. Then another, and another. 6 rockets in 10 seconds, each one screaming its arrival, each detonation walking closer to his position. The blast wave from the final impact lifted Volkov off his feet and slammed him into the trench wall. His ears rang, his vision blurred. Around him, men who had survived months of brutal combat cowered in terror, their nerves shattered not by the physical damage alone but by that sound, that terrible, unforgettable sound. The Germans called it Nebelwerfer, fog thrower, a deceptively innocent name for a weapon of psychological destruction. The Allies would give it nicknames that captured its true nature. Screaming Mimi, moaning Minnie. The sound of approaching death wrapped in a howl that haunted soldiers' nightmares for decades after the war ended. The story of how Germany developed one of World War II's most terrifying weapons begins not in the laboratories of the Third Reich, but in the aftermath of Germany's defeat in World War I. The Treaty of Versailles, signed in 1919, systematically dismantled German military power. Germany was forbidden to possess heavy artillery, tanks, military aircraft, or submarines. The victorious Allies believed they had neutered the German military machine forever. But the treaty writers made a critical oversight. In their comprehensive list of forbidden weapons, they said nothing about rockets. German military planners spotted this loophole almost immediately. In 1930, the German General Staff quietly established a rocket research station at Kummersdorf near Berlin. The official purpose was scientific research. The actual goal was to develop bombardment weapons that could deliver the firepower of heavy artillery without technically violating the Versailles Treaty. The man who would revolutionize rocket warfare was Colonel Walter Dornberger, a brilliant engineer who understood that rockets offered unique advantages over conventional artillery. Artillery shells required thick steel casings to withstand the explosive forces of propellant charges. Rockets, with their gentler acceleration, could use thin-walled casings that devoted more volume to explosive payload. A rocket weighing the same as an artillery shell could carry nearly twice the destructive force. But rockets had a fundamental problem. They were wildly inaccurate. Early rocket designs placed the motor at the rear, pushing the warhead through the air. Any slight irregularity in motor burn would push the nose off, course sending the rocket tumbling through the sky. Some rocketeers tried using fins for stabilization, like arrows. Others experimented with spin stabilization, like rifle bullets. The British Army's Hales war rocket in the 1870s had used angled exhaust vents to spin the rocket, but with limited success. Swedish inventor Baron Unge had refined the concept further, but still couldn't solve the accuracy problem. Dornberger's team at Kummersdorf looked at the problem from a completely different angle. Instead of pushing the warhead, why not pull it? In a revolutionary design that would define all German rockets for the next 15 years, they moved the rocket motor to the front of the projectile. The warhead sat in the rear. Exhaust vents positioned about 2/3 down the length of the rocket expelled gases at a carefully calculated angle, spinning the entire assembly as it flew. The rocket motor pulled the warhead through the air like a tractor pulling a trailer, inherently more stable than pushing from behind. The Germans had solved the rocket accuracy problem. By the late 1930s, Dornberger's team had perfected a 15-centimeter rocket design that would become the most widely produced German rocket of the war. The 15-centimeter Wurfgrund 41 rocket was an engineering marvel disguised in a simple cylindrical shell. The weapon weighed 34.2 kilograms, with 5.62 kilograms of high explosive packed into the rear warhead section. 7 sticks of solid fuel propellant formed the motor at the front. 26 exhaust ventures drilled at a precise 14-degree angle ringed the body about 2/3 from the nose. When the motor ignited, hot gases screamed through these angled vents, spinning the rocket at hundreds of revolutions per minute, while simultaneously propelling it forward. The spin stabilization worked brilliantly. The Germans achieved accuracy comparable to mortars, far better than any previous rocket system. but that unusual exhaust arrangement created an unexpected side effect. As the rocket flew through the air, those 26 angled vents didn't just spin the projectile, they sang. The vents acted like organ pipes, creating a distinctive rising and falling howl that could be heard for miles. The sound was unlike anything soldiers had encountered before, not the shriek of an artillery shell cutting through air at the supersonic speeds, not the whistle of a falling bomb. This was a low, droning wail that started as a distant moan and built to a terrifying crescendo as the rocket approached, ending in the thunderclap of detonation. German weapons designers initially considered the sound a flaw, something to be engineered away in future designs. They had no idea they had accidentally created a weapon of psychological warfare more effective than anything they could have deliberately designed. The launcher for this revolutionary rocket was equally innovative. German engineers adapted the wheeled carriage from the 3.7cm Pak-36 anti-tank gun, mounting 6 steel tubes in a circular arrangement. Each tube measured 1.3 meters long and 16 centimeters in diameter, just slightly larger than the 15-centimeter rocket it would fire. The tubes were electrically wired to a firing mechanism that sat safely distant from the launcher. A magneto system allowed the crew to fire the rockets individually or in automatic sequence. The entire weapon weighed 510 kilograms unloaded, 770 kilograms with all 6 rockets in place. 2 large steel wheels and a tow bar made it mobile enough for a light truck or half-track to pull into position. A stabilizer leg at the front provided support during firing. The system was designated 15cm Nebelwerfer 41, smoke thrower. The name was deliberate camouflage. The weapon had been developed by the Nebeltruppen, German chemical corps units, originally responsible for smokescreens and theoretically chemical warfare. By calling it a smoke thrower, the Germans obscured its true purpose. This was not a smoke generator. This was a rocket artillery system designed to deliver concentrated high-explosive bombardment with unprecedented speed and surprise. The first Nebelwerfer units were organized in early 1941, just months before Germany's invasion of the Soviet Union. Each battery consisted of 6 launchers operated by specially trained crews. 3 batteries formed a battalion. 3 battalions formed a Werfer brigade. The organizational structure emphasized mobility and concentration of fire. A full Werfer brigade could deliver 324 rockets in less than 2 minutes, blanketing an area the size of 2 football fields with explosives. The tactical doctrine emphasized surprise and rapid displacement. Nebelwerfer crews would move into position under cover of darkness or during lulls in combat. They would calculate firing solutions for pre-selected targets, enemy assembly areas, supply depots, artillery positions, fortified positions. When the order came, they would fire their volleys in rapid succession and immediately begin moving to a new position. Because the distinctive smoke trails and sound gave away their location instantly, staying in place after firing meant certain death from counter-battery fire. The weapon could be reloaded in 90 seconds by a trained crew, allowing 3 6-rocket volleys every 5 minutes. But doctrine emphasized firing a devastating initial salvo and then displacing. The first strike was everything. Surprise was everything. The psychological impact was everything. The Nebelwerfer entered combat during Operation Barbarossa, Germany's June 1941 invasion of the Soviet Union. Soviet troops encountered this new weapon with complete confusion and mounting terror. They reported a mysterious German superweapon that made an ungodly shrieking sound and seemed to strike from nowhere with devastating explosive force. Some Soviet soldiers believed the Germans were using some kind of aerial bomb delivered by invisible aircraft. Others thought it was a new type of heavy mortar or perhaps rocket-propelled artillery shells. Rumours spread that the sound itself was some kind of sonic weapon designed to drive men insane. The psychological effect was immediate and profound. Soldiers who had endured conventional artillery bombardment without breaking found themselves paralyzed with fear when the Nebelwerfer struck. The sound gave them just enough warning to know death was coming, but not enough time to take meaningful cover. The rising wail built anticipation and dread. Men found themselves counting seconds, knowing the explosion was imminent but not knowing exactly when it would arrive. That anticipation, combined with the alien sound itself, proved more psychologically damaging than the physical destruction. The Germans discovered something their weapons designers hadn't anticipated. The Nebelwerfer's psychological impact far exceeded its actual destructive capacity. A battery of 6 launchers firing 36 rockets delivered less total explosive tonnage than a similar artillery barrage. But the effect on enemy morale was vastly greater. Soldiers who could endure artillery fire without flinching would break and run when the Nebelwerfer's howl filled the air. German after-action reports from the Eastern Front consistently noted that Nebelwerfer bombardment produced disproportionate results. Soviet attacks would falter, defensive positions would be abandoned. Even seasoned Soviet troops who had survived the brutal early months of the campaign showed visible signs of fear when they heard that distinctive sound. For over a year, the Germans managed to keep the Nebelwerfer's true nature a secret from Allied intelligence. Soviet troops reported the mystery weapon but could offer little technical detail. They knew it made a terrible sound, they knew it delivered concentrated explosive force. They didn't know what it looked like or how it worked. The secret was finally revealed in January 1943 when Soviet forces captured the city of Velikiye Luki in western Russia. Among the equipment abandoned by retreating German forces were several intact Nebelwerfer launchers complete with ammunition. Soviet engineers examined the captured weapons with fascination and immediately recognized the brilliance of the design. The revelation that the mystery weapon was simply a rocket launcher went a long way toward dispelling the more fantastical rumors circulating among Soviet troops. The Soviets were already using their own rocket artillery, the famous Katyusha systems that German soldiers called Stalin organs. Knowing that the Nebelwerfer was just another rocket weapon, albeit an exceptionally well-designed one, helped reduce its psychological impact. You could understand a rocket launcher. You could calculate its range, estimate firing positions, organize counter-battery fire. It was no longer a mysterious superweapon, but a conventional threat that could be countered with conventional tactics. But understanding what the Nebelwerfer was didn't eliminate the fear it inspired. That sound remained. Even soldiers who knew exactly what was coming, who had survived multiple Nebelwerfer attacks, who intellectually understood they were facing a conventional weapon, still felt their guts clench when they heard those first distant moans rising toward a howling crescendo. The weapon had imprinted itself on a primal level. The sound meant death. Logic and knowledge couldn't override that basic equation. As the war progressed, the Germans developed larger variants of the Nebelwerfer system. The 21cm Nebelwerfer 42 fired 5 rockets instead of 6 from a similar wheeled carriage. Each rocket weighed considerably more than the 15cm version and carried 22.4 kilograms of high explosive. 22 angled exhaust ventures set at 16-degree angles provided spin stabilization. The 21cm rocket could reach targets at 7,050 meters, significantly farther than the 15cm version's 6,900-meter maximum range. The larger rockets produced an even deeper, more resonant howl during flight. Veterans reported that you could distinguish between 15cm and 21cm Nebelwerfer fire by sound alone. The larger rockets produced a lower-pitched moan that built to a thunder-like roar. Over 400 launches and 400,000 rockets of the 21cm type were produced during the war. Even larger rockets followed. The 28cm and 32cm Nebelwerfer 41 rockets shared the same motor but carried different warheads. The 28cm version delivered high explosive. The 32cm rocket carried incendiary compounds designed to start fires in wooden structures and set fuel and ammunition dumps ablaze. These heavy rockets had a severe limitation. Their maximum range was only 200 meters, barely over a mile. This short range made them primarily useful for direct support of infantry attacks or in siege warfare against fortified positions. The heavy rockets could be fired from their wooden packing crates, from simple frame launchers, or from vehicle-mounted racks. The most famous vehicle-mounted Nebelwerfer was the Panzerwerfer 42, a self-propelled rocket launcher mounted on a modified Opel Maltier half-track. The Germans had recognized that the Nebelwerfer's distinctive signature made rapid displacement essential for crew survival. Towed launchers required several minutes to limber up and move. A self-propelled system could fire its salvo and be moving within seconds. The Panzerwerfer mounted 10 launch tubes in 2 horizontal rows of 5 on the armoured body of the Maltier half-track. The tubes could traverse 270 degrees and elevate to 80 degrees, providing excellent flexibility in targeting. The vehicle carried 20 rockets total, 10 loaded in the tubes and 10 stored inside the armoured hull, enough for 2 full salvos before requiring resupply. A crew of 3 to 4 operated the weapon. A defensive machine gun mounted above the cab provided protection against infantry attack. The Panzerwerfer could reach speeds of 40 km per hour on roads, allowing it to keep pace with advancing panzer formations. Production began in April 1943, and by March 1944, 300 Panzerwerfers had been delivered to German rocket units. The vehicle proved especially valuable in mobile warfare on the Eastern Front, where rapid advances and fluid battle lines made static artillery positions vulnerable. Allied troops first encountered the Nebelwerfer during the Sicily campaign in July 1943. American GIs landing on Sicilian beaches heard a sound unlike anything in their experience, a rising howl that seemed to come from the sky itself, building to an ear-splitting crescendo before the ground erupted in fire and shrapnel. The Americans immediately dubbed it Screaming Mimi. British and Canadian forces encountering the same weapon called it Moaning Minnie. Both nicknames captured the psychological essence of the weapon better than its technical German designation. One American infantryman later recalled, "The sound went right through you. Artillery you could kind of ignore if it wasn't landing too close. You got used to the noise, but that screaming, that was different. It got into your head, made you want to dig deeper, run faster, do anything to get away from that sound." The nicknames spread rapidly through Allied forces. Soldiers who had never encountered a Nebelwerfer knew the terms Screaming Mimi and Moaning Minnie before they first heard the weapon's distinctive howl. The names became part of the shared vocabulary of combat, like 88 for the German 88mm flak gun or Stuka for the Junkers 87 dive bomber. Unlike technical designations, these nicknames carried emotional weight. They communicated not just what the weapon was, but how it made you feel. During the Normandy campaign of June through August 1944, Nebelwerfer units played a significant role in German defensive operations. The 7th Werfer Brigade, consisting of the 83rd and 84th Werfer regiments, arrived in the Normandy area on June 10th, just 4 days after the Allied landings. The brigade set up positions near Caen and immediately began bombarding British and Canadian forces, attempting to push inland from the beaches. The 7th Werfer Brigade would fire 8,000 tons of ammunition during the Normandy campaign, much of it concentrated on the fighting around Hill 112 during Operation Jupiter in late June. British troops attacking German positions on this strategic hilltop found themselves advancing under near-constant Nebelwerfer bombardment. The concentrated rocket fire proved devastating against troops moving in the open. Even more significantly, it disrupted communications, destroyed morale, and forced British commanders to slow their advance while they dealt with the rocket threat. Other Werfer units deployed to Normandy included the 8th Werfer Brigade with its 2 regiments, the 1st Werfer Lehr Regiment and the 2nd Heavy Werfer Regiment. SS units deployed, their own Nebelwerfer battalions including the 101st SS Werfer Abteilung attached to the 2nd SS Panzer Division, Das Reich, and the 102nd SS Werfer Abteilung. By mid-July 1944, British intelligence counted at least 50 Nebelwerfer launchers active in the Normandy sector, though this was certainly an undercount as many launchers remained undetected. Allied counter-battery efforts specifically targeted Nebelwerfer positions. The distinctive smoke trails produced by rocket launches made Nebelwerfer batteries easy to locate once they fired. Allied artillery observers were trained to immediately call for counter-battery fire the moment they spotted rocket smoke trails, or heard the characteristic sound. But the Germans had anticipated this threat. Nebelwerfer doctrine emphasized firing and displacing within 90 seconds. A well-trained crew could unleash their salvo and be moving before counter-battery shells began landing on their former position. The cat-and-mouse game between Nebelwerfer crews and Allied counter-battery units became a constant feature of the Normandy campaign. German rocket crews would set up multiple pre-surveyed firing positions. They would move into one position, fire a salvo, and immediately displaced to another position several hundred meters away. By the time Allied shells arrived at the first firing position, the German crew was already setting up at the second position, or had moved to a third hide site to wait out the counter-battery bombardment. This tactical flexibility made Nebelwerfer units far more survivable than conventional artillery, which required more time to displace and couldn't move as easily through difficult terrain. The Battle of the Bulge in December 1944 showcased the Nebelwerfer's capacity for creating chaos and terror in the opening hours of an offensive. Hitler's desperate gamble to split the Allied armies in Western Europe relied heavily on achieving complete surprise. Nebelwerfer units would play a critical role in the initial German bombardment. On the morning of December 16, 1944, American troops in the Ardennes forest awakened to thick fog blanketing the mountainous terrain. Then the sound began. Veterans of the Battle of the Bulge consistently described the Nebelwerfer fire that opened the German offensive as one of the most terrifying experiences of their lives. One witness described seeing eerie red and purple lights streaking through the pea soup fog, traces from German guns mixed with rocket exhaust flames. Then came the bone-chilling sound of screaming mimes, hundreds of rockets howling through the fog like demons. The ground shook with continuous detonations, trees shattered. The frozen earth erupted in geysers of dirt and snow. Dug-in American positions simply ceased to exist, buried under avalanches of explosives. The Nebelwerfer bombardment, combined with conventional artillery fire, achieved exactly what German planners intended. It created shock, confusion and terror among American units that had been treating the Ardennes as a quiet sector where new troops could gain combat experience. 2 regiments of the 106th Infantry Division were quickly surrounded and cut off, leading to the surrender of over 6,800 American soldiers, the largest mass surrender of US forces in the European theatre. Veterans who survived the opening bombardment spoke of the Nebelwerfer's sound haunting them for decades. One American soldier, a veteran who had fought across France without breaking, later said, "I'd been through artillery bombardment before, plenty of times. But that sound in the bulge, that was different. It wasn't just the explosions. It was that screaming, like the sound of hell itself. I can still hear it sometimes, 60 years later. I wake up and I can hear that sound." The psychological impact of the Nebelwerfer extended beyond the immediate moment of attack. Soldiers who had been subjected to Nebelwerfer fire developed a kind of conditioned response. Hearing any sound that even remotely resembled that distinctive howl, a distant siren, wind through telegraph wires, certain types of aircraft engines, could trigger intense anxiety reactions. Medical officers noted cases of what they called Nebelwerfer neurosis, or screaming mimi syndrome, psychological conditions where soldiers became effectively combat ineffective after repeated exposure to rocket attacks. The physical wounds healed, the psychological wounds persisted. The German use of Nebelwerfer systems in Italy presented unique tactical challenges. The mountainous terrain of the Italian peninsula created acoustic effects that amplified and distorted the rocket's sound. Valleys and canyons channeled the noise, sometimes making it seem like rockets were coming from multiple directions simultaneously. Allied troops advancing through Italian mountain passes reported hearing the Nebelwerfer's howl echoing off cliffs and mountainsides, the sound seeming to come from everywhere and nowhere. In urban combat, particularly during the fighting around Cassino, Nebelwerfer units demonstrated the weapon's effectiveness against fortified positions. The concentrated blast effect of multiple rockets detonating in quick succession could collapse buildings, bury defenders under rubble, and create choking clouds of dust that made organised defence nearly impossible. One British officer, writing in his diary after a Nebelwerfer attack on his company's position in a small Italian town, described the aftermath. The building simply came down, not blown apart like with aerial bombs, but collapsed, pancaked from the combined shock of multiple explosions. We had men buried alive, others were trapped in cellars. The dust was so thick you couldn't see 3 meters, and that damned sound, echoing off what was left of the walls, made you think there were 100 launchers firing instead of 6. The acoustic properties of the Nebelwerfer made it especially effective in night attacks. The sound provided psychological preparation for the physical attack. German infantry would time their assaults to begin the moment the rocket bombardment ended. Defenders, disoriented by the noise and explosions, their night vision destroyed by rocket flashes, their ears ringing from the blasts, found themselves facing charging German troops before they could recover their composure and organize a defense. The technical limitations of the Nebelwerfer system became more apparent as the war progressed and Allied forces adapted to the threat. The weapon's accuracy, while superior to early war rockets, was still significantly worse than conventional artillery. The circular error probable for the 15-centimeter rocket was approximately 200 meters at maximum range. This made the Nebelwerfer an area weapon, effective against troop concentrations, supply dumps and other large targets, but useless for precision strikes against specific point targets like bunkers or individual vehicles. The reloading process, while achievable in 90 seconds under ideal conditions, often took significantly longer in combat. Each rocket had to be manhandled into its tube, an awkward process made more difficult by darkness, enemy fire, or difficult terrain. Ammunition supply was a constant challenge. Each rocket weighed over 34 kilograms for the 15-centimeter version. A full reload for a 6-tube launcher required moving more than 200 kilograms of rockets, plus handling the heavy tubes and firing mechanisms. Ammunition carriers had to follow the launchers, increasing the logistics burden and making the entire unit more vulnerable to detection and attack. The distinctive signature of the weapon, initially an advantage in terms of psychological impact, became a liability as Allied forces developed counter-tactics. Artillery spotters were specifically trained to recognize rocket smoke trails and immediately call for counter-battery fire. Allied fighter bombers prowling behind German lines learned to watch for the telltale smoke columns that marked Nebelwerfer positions. The ammunition itself presented manufacturing challenges that limited production compared to conventional artillery shells. The unique design with the motor at the front and warhead at the rear required precision machining to ensure proper balance and spin characteristics. The 26 exhaust ventures on each 15-centimeter rocket had to be drilled at exactly 14 degrees from axis, within tight tolerances, or the rocket would fly erratically. The 7 sticks of solid propellant had to burn evenly, or the rocket would tumble. Quality control was critical, and quality control required time and skilled labor, resources that became increasingly scarce as the war turned against Germany. By late 1944, ammunition shortages began affecting Nebelwerfer operations. Units that had fired freely in 1942 and 1943 found themselves rationed to a few salvos per day or restricted to firing only during major operations. The German industrial system, already straining under Allied bombing and the demands of a two-front war, couldn't produce enough rockets to keep the Werfer brigades at full effectiveness. Despite these limitations, nearly 6,000 Nebelwerfer 41 launchers and approximately 5.5 million 15-centimeter rockets were manufactured during the war. Add the 21-centimeter variants with 400 launchers and 400,000 rockets, plus the heavy 28-centimeter, 30-centimeter, and 32-centimeter systems, and total German rocket production exceeded 6.7 million rounds. Allied intelligence services studied the Nebelwerfer with intense interest. Captured launchers were shipped back to Britain and the United States for detailed technical analysis. Engineers marveled at the elegant simplicity of the design. The spin stabilization system, the innovative motor placement, the efficient use of materials all represented solutions to problems that Allied rocket designers were still wrestling with. American weapons developers were particularly impressed. The United States was developing its own rocket systems, but had not yet achieved the accuracy and reliability of the German designs. In late 1944, the US Army copied the 21-centimeter Nebelwerfer design, producing it as the 210mm T-36 system for testing and evaluation. British intelligence reports on the Nebelwerfer highlighted both its tactical effectiveness and its psychological impact. One report from 1944 stated, "The Nebelwerfer is perhaps the most psychologically destructive weapon the Germans possess. While its actual destructive power is less than comparable artillery, its effect on troop morale is vastly greater. The distinctive sound appears to trigger fear responses that conventional bombardment does not. Troops subjected to Nebelwerfer fire show signs of stress disproportionate to the actual casualties inflicted." The report went on to note that German forces used the Nebelwerfer specifically as a terror weapon, timing bombardments for maximum psychological effect. Night attacks to disrupt sleep and fray nerves. Pre-assault bombardments timed to begin exactly 60 seconds before German infantry attacked, giving Allied troops just enough time to recognize the threat, but not enough time to properly prepare. Harassment fire at irregular intervals to prevent rest and recovery. The Germans understood what they had created. This was not just an artillery system. This was a weapon that attacked the mind as much as the body. Soviet forces, having borne the brunt of Nebelwerfer attacks for most of the war, developed their own counter-tactics. Soviet doctrine emphasized dispersal and hardening of positions. Instead of concentrating troops in assembly areas where they would be vulnerable to area bombardment, Soviet commanders spread units out across wider frontages. Forward positions were heavily fortified with deep bunkers and covered trenches that could withstand the blast effects of rocket fire. Soviet counter-battery tactics were particularly aggressive. Any detection of Nebelwerfer fire triggered immediate and overwhelming artillery response. Soviet artillery doctrine called for firing 10 to 20 times the ammunition expenditure of the detected German battery, saturating the suspected launch area with shells to ensure destruction or at least suppression of the German rocket unit. Soviet troops were also taught to recognize and report Nebelwerfer signatures quickly. Political officers emphasized that the Nebelwerfer was just a weapon, not a mysterious superweapon. Understanding the mechanics of the weapon reduced its psychological impact. Knowing that the distinctive sound came from exhaust vents, not from some deliberate sonic weapon, helped soldiers rationalize their fear. By 1944, veteran Soviet units had adapted to the Nebelwerfer threat sufficiently that its psychological impact was significantly reduced on the Eastern Front. This adaptation was not universal. New units, encountering the weapon for the first time, still experienced the same terror that had paralyzed Soviet troops in 1941. But experienced formations had developed coping mechanisms and tactical responses that made them far more resilient. On the Western Front, where Allied forces encountered the Nebelwerfer later in the war, the psychological impact remained potent through the war's end. American and British troops in Normandy, the Low Countries and Germany reported the same intense fear reactions that Soviet troops had experienced years earlier. The weapon's effect on morale never fully diminished, even among veteran units. German rocket crews developed a professional pride in their weapon and their ability to deliver devastating surprise attacks. Nebelwerfer units were considered elite formations within the German army. The technical skill required to accurately survey firing positions, calculate trajectories, and time salvos for maximum effect meant that Werfer battalions attracted above-average personnel. The danger of operating Nebelwerfers created a certain fatalism among crews. They knew that the moment they fired, they had painted a target on their position. Every second they remained after launching was a second closer to Allied shells landing on their heads. This created a culture of speed and efficiency. Crews competed to see who could fire and displace fastest. 90 seconds from last rocket launch to wheels rolling became a point of pride. Some exceptional crews could manage it in 60 seconds, though this required near-perfect coordination and a bit of luck. The crews gave their launchers nicknames, often darkly humorous. One unit called their Nebelwerfer the Screaming Death, in acknowledgement of what Allied troops called it. Another crew painted Lullaby Singer on their launcher's trail, a sardonic reference to the weapon's ability to put enemy soldiers into permanent sleep. The black humour was a coping mechanism for the constant danger and the knowledge of what their weapon did to men on the receiving end. There were moments of grace, instances where the impersonal machinery of war revealed human dimensions. One German Nebelwerfer crew commander, interviewed after the war, recalled an incident from the Normandy campaign. His unit had been firing harassment missions against a British position for several days. On the fourth night, after firing their salvo and preparing to displace, they found a small wooden sign that British troops had somehow managed to plant near their position during the day. The sign, written in crude German, read, "Thank you for the nightly concerts, your devoted British audience. P.S. Please learn some new tunes." The German crew commander said his men laughed harder at that sign than at anything in months of war. They left a response sign before moving to a new position. "Apologies. New material coming soon. Your German musicians." The next night they fired from a different position, as doctrine required. The psychological game continued, but that brief moment of humour acknowledged a shared humanity beneath the killing. Such moments were rare. More common were the grim realities of what the Nebelwerfer did to human bodies and minds. Medical officers treating soldiers who had survived Nebelwerfer attacks reported injuries that differed in character from conventional artillery wounds. The concentrated blast effects of multiple rockets detonating in a small area produced massive overpressure damage. Soldiers could be killed by internal injuries with no visible external wounds, their organs ruptured by blast waves that passed through their bodies. The fragmentation patterns from Nebelwerfer rockets produced distinctive wound signatures. The warhead placement at the rear of the rocket, combined with detonation, while the rocket was still airborne or just impacting, created a wider spread of fragments than conventional artillery shells that buried themselves before detonating. Survivors often bore dozens of small fragment wounds across their entire bodies, rather than the concentrated wound patterns typical of artillery. The psychological casualties outnumbered the physical casualties by significant margins. For every soldier killed or wounded by Nebelwerfer fire, 2 or 3 more would require evacuation for combat stress reactions. Some recovered with a few days of rest. Others never returned to frontline duty. A small percentage would carry the psychological scars for the rest of their lives, waking decades later in the night to the remembered sound of that howling approach. The Germans experimented with using Nebelwerfer systems in anti-aircraft roles with limited success. The 21-centimeter rocket was adapted as the Werfer Granit 21, an air-to-air weapon designed to break up Allied bomber formations. The concept was to fire rockets into bomber formations from German fighter aircraft, the explosions and shrapnel forcing the bombers to scatter and making them vulnerable to follow-up attacks by fighters. With conventional weapons, several German aircraft types carried underwing Werfer Granit 21 launchers. The Focke-Wulf FW-190 could mount 2 21-centimeter rockets, one under each wing. The Messerschmitt Me-110 and Me-410 had launchers for 4 rockets, 2 under each wing, with some Me-410 variants capable of carrying 6 rockets. Even the revolutionary Me-262 jet fighter was equipped to carry 21-centimeter rockets for bomber attacks. The air-launched rockets had mixed results. They were effective at forcing bomber formations to scatter, disrupting the tight defensive formations that made American daylight bombing raids possible. But actually hitting bombers with unguided rockets proved extremely difficult. Most air-launched rockets missed their targets by wide margins. The psychological effect on bomber crews was significant, however. Seeing a salvo of rockets streaking toward their formation, trailing the characteristic smoke and hearing that distinctive howl even over engine noise, unnerved even veteran crews. The rocket attacks forced evasive maneuvers that broke up formations, opened bombers to follow up fighter attacks, and degraded bombing accuracy. In this role, the Nebelwerfer rocket served its purpose even when it missed. The threat was as effective as the actual weapon. By early 1945, the German military situation had deteriorated to the point where Nebelwerfer operations became increasingly limited. Ammunition shortages meant that many launchers sat idle. Fuel shortages restricted the mobility that was essential to Nebelwerfer doctrine. Personnel shortages meant that experienced crews were not replaced when they became casualties. Allied air superiority made daylight movement almost suicidal. Nebelwerfer units found themselves restricted to night operations, further limiting their effectiveness. The units that remained active fought with a certain desperation. Knowing that Germany was losing the war, Nebelwerfer crews continued firing their salvos and running the gauntlet of counter-battery fire because that was what soldiers did. They fired, they displaced. Sometimes they survived to fire again, often they didn't. The last major Nebelwerfer deployment was during the defense of Germany itself in early 1945. Werfer brigades were scattered along the Rhine River and later in the defense of Berlin. They fired until they ran out of ammunition, then fell back. They fired again from new positions until those too were overrun. In the final weeks of the war, some Nebelwerfer crews destroyed their launchers rather than let them fall into Allied hands. Others simply abandoned the weapons and melted into the chaos of Germany's collapse. The Americans captured hundreds of Nebelwerfer launchers, along with technical documents and thousands of rockets. Soviet forces also captured significant numbers of launchers and took German rocket engineers prisoner. Adding German rocket technology to their own already advanced programs, British forces captured launchers in Normandy and Germany, sending them back to Britain for detailed study. After the war, the Nebelwerfer influenced rocket artillery development worldwide. The Soviet BM-21 Grad, introduced in the 1960s and still in service today, owes design elements to both the Soviet Union's own Katyusha and captured German Nebelwerfer technology. The American M270 multiple launch rocket system, entering service in the 1980s, traces its conceptual lineage through various Cold War systems back to the World War II-era rocket launchers, including the Nebelwerfer. The basic concept of using multiple rocket launchers for concentrated firing and displacing rapidly, using the psychological impact of massed rocket fire as a force multiplier, all of these elements that the Germans refined with the Nebelwerfer, became standard in modern rocket artillery. The Nebelwerfer had proven the concept even though Germany lost the war. Veterans who faced the Nebelwerfer remembered it as one of the most terrifying weapons of the war, not the most destructive. Allied bombing raids killed far more people, not the most advanced. The atomic bomb redefined warfare. But for sheer psychological impact on soldiers in the field, few weapons matched the screaming Mimi. One British veteran, speaking at a reunion 50 years after the war, summed up the experience. "You never forgot that sound. Once you heard it, it stayed with you. I can close my eyes right now and hear it perfectly. That rising moan building to a howl. You knew you had about 3 seconds from the moment you heard it until impact. 3 seconds to pray, to dive for cover, to make peace with your mortality. Then the world would explode. If you survived, you'd lie there shaking, and the worst part was knowing you'd hear that sound again. It was always out there, waiting. The screaming Mimi never slept." The Nebelwerfer represented a transitional technology in weapons development, too inaccurate for precision strikes but too powerful to ignore, too resource-intensive for Germany's declining industrial capacity but too effective to abandon, too terrifying for soldiers to face calmly but too vulnerable to counter battery fire to dominate the battlefield. It was a weapon that succeeded by terrifying rather than by destroying, by attacking morale rather than by inflicting casualties, by making soldiers afraid rather than by killing them. In the end, the Nebelwerfer couldn't save Germany from defeat. No weapon could have, not given the overwhelming material superiority of the Allied coalition and the strategic errors of German leadership. But the Nebelwerfer left its mark on everyone who encountered it. The sound became part of the collective memory of World War II, as recognizable to veterans as the drone of B-17 bombers, the rattle of MG-42 machine guns, or the whistle of falling bombs. At the Imperial War Museum in London, a restored 15cm Nebelwerfer 41 sits in a display case among other weapons of the Second World War. Visitors walk past reading the placard that lists its specifications and deployment history. Most move on quickly. It's just another piece of old military hardware. But occasionally a very old man will stop and stare at the launcher. His eyes will go distant. Sometimes his hands will tremble slightly. He's hearing a sound that the museum cannot recreate, a sound that once filled his world with terror, a sound that decades of peace cannot erase, the howl of the screaming Mimi, echoing across the years. The technical specifications of the Nebelwerfer reveal the sophistication hidden beneath its simple appearance. Each 15cm rocket was precisely engineered to tolerances that would have been considered exceptional in peacetime manufacturing. The 7 propellant sticks were cast from Diglicol powder, a solid fuel that burned at a carefully controlled rate. Each stick was identical in weight to within half a gram, ensuring even thrust during flight. Variation beyond this tolerance would cause the rocket to veer off course or tumble. The warhead section contained not just high explosive, but a carefully designed fragmentation sleeve. Unlike artillery shells that used the shell casing itself for fragmentation, the Nebelwerfer rocket's thin walls couldn't provide effective fragmentation. Instead, German engineers surrounded the explosive charge with a pre-notched steel sleeve that would break into predictable fragment sizes upon detonation. The fragments were large enough to retain lethal velocity, but small enough to create a wide dispersal pattern. The fuse system was equally sophisticated. Early Nebelwerfer rockets used simple impact fuse that detonated on contact, but these proved less effective than desired, as rockets hitting soft ground would bury themselves before detonating, reducing the fragmentation effect. Later production rockets incorporated fuse with short delays, measured in hundredths of a second, that allowed the rocket to impact and begin compressing into the ground before detonation. This shallow burial was optimal, throwing fragments forward and to the sides rather than wasting energy, by driving fragments deep into the earth. Some rockets were fitted with proximity fuses that would detonate the warhead a few meters above ground, creating an airburst effect that maximized casualty radius. These fuses used a simple mechanical system, triggered by air pressure changes as the rocket descended. The Germans couldn't afford the complex electronic proximity fuses that American forces were developing, but the mechanical system worked adequately for its intended purpose. The electrical firing system that connected the launcher to the firing post represented another area of German ingenuity. Each rocket tube had an electrical contact that completed a circuit when the rocket was properly seated. The firing mechanism could detect which tubes were loaded and would skip empty tubes during automatic sequential firing. This prevented the dangerous situation of attempting to fire an empty tube, which could arc and potentially ignite propellant residue. The cables connecting the firing post to the launcher were armoured and waterproofed, designed to survive being dragged through mud, snow, and across rough terrain. The firing post itself was housed in a metal case about the size of a large briefcase, with a hand-cranked magneto-generator that produced the electrical charge needed to ignite the rocket motors. No batteries were required, eliminating one potential failure point. A trained operator could fire all 6 rockets individually, with approximately 1-second intervals, or could set the mechanism for automatic fire that would discharge all 6 rockets in roughly 10 seconds. The automatic fire sequence was timed to provide slight delays between each rocket to prevent the blast from one rocket interfering with the launch of the next. The launcher carriage, adapted from the PAC-36 anti-tank gun, proved remarkably durable. The split trail design provided excellent stability during firing. The 2 large wheels, identical to those used on various German artillery pieces, meant that replacement wheels were readily available from depot stocks. The traverse and elevation mechanisms were simple worm gears that could be operated manually without power assistance. This mechanical simplicity meant fewer things could break, and repairs could be made in the field with basic tools. The crew positions around the Nebelwerfer were carefully designated for efficiency and safety. The commander stood behind and to the side of the launcher, observing the target area and directing fire. 2 loaders worked in tandem to manhandle the heavy rockets from their transport racks to the launch tubes. 1 man operated the firing mechanism from the distant firing post connected by 15 meters of cable. Additional crew members prepared the next reload, uncrating rockets and checking fuses. A full reload drill required precise choreography. The moment the last rocket left its tube, loaders would sprint forward with the first replacement rocket. Each 34-kilogram rocket had to be lifted to shoulder height and guided into the tube mouth, then pushed fully into the tube until it seated against the electrical contact. The rocket had to be oriented correctly, with the exhaust ventures facing rearward. Loading a rocket backwards would be catastrophic, as the motor would fire directly into the tube, likely killing the crew and destroying the launcher. To prevent this, each rocket had a distinctive coloured band at the nose end, and raised lettering indicating proper orientation. Loading was done by feel as much as by sight, especially during night operations when lights were forbidden near the launcher. The ammunition supply chain for Nebelwerfer units was a constant challenge. Each rocket was shipped in a wooden crate that also served as a storage container and humidity barrier. The solid propellant was hygroscopic, meaning it would absorb moisture from the air if not properly sealed. Damp propellant would burn unevenly, causing erratic flight or even motor failure. Ammunition dumps storing Nebelwerfer rockets required careful inventory management to ensure older stocks were issued first, and that storage conditions remained dry. The wooden crates were bulky and heavy. A truck carrying Nebelwerfer ammunition could transport far fewer rounds than the equivalent weight in conventional artillery shells. This meant more trucks, more fuel consumption, and more strain on Germany's already overtaxed logistics system. By 1944, fuel shortages meant that ammunition trucks often couldn't reach forward units, forcing Nebelwerfer crews to manhandle ammunition over the last few kilometers to their firing positions. Moving 34-kilogram rockets through muddy terrain or across broken ground was exhausting work. Crews would rig improvised sleds or use captured equipment to ease the burden, but ammunition supply remained a limiting factor in Nebelwerfer operations throughout the war. The sound that made the Nebelwerfer legendary was, as mentioned, an accident of engineering. But once German commanders recognized its psychological value, some proposed deliberately enhancing the effect. One suggestion was to add whistles or sirens to the rockets, specifically to increase the terror factor. This idea was rejected on practical grounds. Any addition to the rocket would affect its weight distribution and flight characteristics. The rockets were already operating at the edge of acceptable accuracy. Adding non-functional components would degrade performance for questionable psychological benefit. The existing sound was already effective beyond any reasonable expectation. Another proposal suggested developing a smokeless propellant to make the rocket launches harder to detect. This too was rejected. The solid propellant formula was already optimized for performance. Changing it would require extensive testing and retooling of production facilities, all for marginal benefit. The smoke trails were an inevitable consequence of the motor design and couldn't be eliminated without fundamental changes to the entire system. German engineers did experiment with various rocket designs throughout the war. Some featured larger warheads with smaller motors, others reversed the standard design, placing the motor at the rear in conventional configuration. None performed as well as the original design. The forward motor, rear warhead configuration remained the standard because it worked. In a war where resources were increasingly scarce, Germany couldn't afford to replace functional weapons with theoretical improvements. The training pipeline for Nebelwerfer crews became increasingly compressed as the war progressed. In 1941, a Nebelwerfer crewman received several weeks of specialized training at dedicated schools. By 1944, training had been reduced to a few days, with most learning occurring in field units under combat conditions. This decline in training quality showed in operational effectiveness. Inexperienced crews made errors in calculating firing solutions, leading to rockets landing short or overshooting targets. They took longer to reload, increasing their vulnerability to counter battery fire. They sometimes made dangerous mistakes like loading rockets with incorrect fuse settings or failing to properly secure the launcher stabilizer, causing the weapon to shift during firing. Experienced crews were invaluable and were often transferred between units to spread their expertise. A veteran Nebelwerfer gunner who had survived a year of combat was worth his weight in gold. He knew the tricks that textbooks didn't teach: how to judge wind drift by watching grass or trees, how to estimate range to targets when survey equipment wasn't available, how to recognize the sound of incoming counter-battery fire early enough to take cover, how to maintain the launcher in field conditions with improvised tools and materials. The camouflage and concealment of Nebelwerfer positions was an art form. The launchers themselves were relatively small and could be hidden in tree lines, behind buildings, or in reverse slope positions. But the moment they fired, concealment became irrelevant. Those distinctive smoke trails pointed directly back to the launcher position like arrows. German crews became experts at selecting positions that offered rapid exit routes. A firing position wasn't useful unless you could get out quickly. Open fields were avoided. Road junctions were ideal because they offered multiple escape routes. Positions near wooded areas allowed crews to drive into forest cover immediately after firing. Some crews prepared elaborate dummy positions with stripped or destroyed launchers, left visible to draw counter-battery fire away from actual positions. Others used captured Allied equipment as decoys, arranging it to look like ammunition dumps or command posts, hoping to waste Allied artillery on worthless targets. The psychological warfare aspect of the Nebelwerfer extended beyond the sound. German commanders deliberately used Nebelwerfer fire to signal impending attacks. The bombardment would intensify, reaching a crescendo, then stop abruptly. In the sudden silence, Allied troops would hear German infantry advancing. The Nebelwerfer had announced that death was coming in multiple forms. Even troops who had weathered the bombardment without breaking found themselves shaken by the follow-up assault. Their nerves were already frayed, their hearing was compromised, their positions might be damaged. Now they had to fight off determined infantry attacks while still recovering from the rocket barrage. This tactic worked particularly well in night operations. The rocket impacts would light up the darkness with brilliant flashes, destroying the night vision of defenders while simultaneously revealing their positions. German infantry waiting in the darkness beyond the impact zone would have their approach covered by the noise of explosions. By the time the bombardment ended and defenders were trying to recover their night vision and hearing, German troops would be at the wire or even inside the defensive perimeter. Soviet troops developed counter-tactics specifically for this situation. When Nebelwerfer fire began, alert defenders would fire pre-planned defensive concentrations, artillery and mortar fire directed at likely assembly areas for German infantry. The theory was that if Germans were preparing to attack, their infantry must be massing somewhere. Saturating those areas with fire might disrupt the attack before it began. This led to a deadly calculus. German commanders had to balance the psychological benefit of the Nebelwerfer bombardment against the risk of exposing their infantry to counter-battery fire. Sometimes they fired the Nebelwerfers with no follow-up attack planned, simply to harass defenders and force them to expend ammunition on empty ground. Other times they attacked without preliminary bombardment, hoping to achieve surprise. The uncertainty added another layer of psychological pressure on defending troops. The use of Nebelwerfers in siege warfare demonstrated the weapon's versatility. During the siege of Leningrad, German Nebelwerfer units bombarded the city regularly, adding to the suffering of the civilian population. The rockets were particularly effective against wooden structures, which dominated much of Leningrad's residential areas. The combination of blast and fragmentation could collapse buildings or set them ablaze. Soviet accounts from the siege mention the terror caused by the Nebelwerfer attacks. Unlike artillery, which produced a warning whistle giving civilians a few seconds to take cover, the Nebelwerfer's howl seemed to build slowly, giving people time to recognize the threat and become paralyzed with fear before the impacts came. Children who survived the siege recalled the sound decades later, describing nightmares where the howling returned. At Stalingrad, Nebelwerfer units participated in the brutal urban combat. The confined spaces and rubble-filled streets limited the weapon's mobility, but enhanced its psychological impact. The howl of incoming rockets would echo off ruined buildings, making it impossible to determine the direction of attack. Soldiers reported the sensation of being surrounded by the sound, as if rockets were coming from every direction simultaneously. The blast effects in urban terrain were enhanced by the confinement. Rockets detonating in narrow streets or inside buildings created overpressure waves that were channeled and focused by surrounding structures. Soldiers in basements or ground floor rooms could be killed by blast effects alone, even if the rocket detonated a floor above or across the street. Soviet forces eventually captured enough Nebelwerfer equipment to field their own units with German rockets. At least 2 Soviet rocket artillery battalions were equipped with captured Nebelwerfers and German ammunition stocks. These units operated on the Eastern Front in 1943 and 1944, firing German rockets against German forces. The psychological irony was not lost on German troops who found themselves on the receiving end of their own weapon. They knew that sound intimately. They knew what it meant. Hearing it directed at them was deeply unsettling. Several German combat reports from 1944 mention the distinctive sound of Nebelwerfer fire, followed by the shocked realization that the rockets were incoming rather than outgoing. The mental adjustment required, recognizing that your own weapon was being used against you, added a surreal quality to an already nightmarish experience. The Soviets also reverse-engineered elements of the Nebelwerfer design for incorporation into their own rocket systems. The spin stabilization technique in particular interested Soviet engineers. While Soviet Katyusha rockets used fin stabilization, the German spin stabilization system offered some advantages in certain applications. Post-war Soviet rocket designs incorporated elements learned from captured German equipment. The Western Allies were less interested in copying the Nebelwerfer directly. American and British forces had their own rocket systems under development that offered different advantages. The American T-34 Calliope, multiple rocket launchers mounted on Sherman tank chassis, provided mobile firepower similar to the Panzerwerfer. The British land mattress provided massed rocket fire from truck-mounted launchers. These Allied systems generally emphasized quantity of rockets over precision. A single Calliope could fire 60 rockets in rapid succession. A land mattress battery could launch hundreds of rockets in under a minute. The philosophy was different from the German approach. Rather than attempting to achieve reasonable accuracy with a small number of rockets, Allied designers accepted poor accuracy and compensated with massive numbers of rockets fired at once. The result was area saturation on a scale the Germans couldn't match. When a land mattress battery fired a full salvo, the target area was simply obliterated under thousands of pounds of explosives. Nothing survived. But the Allied systems lacked the psychological impact of the Nebelwerfer. The American rockets made a whooshing sound during flight, intimidating but not terrifying. The British rockets were nearly silent until impact. Neither produced the distinctive howl that made the Nebelwerfer uniquely effective as a weapon of terror. German soldiers who experienced Allied rocket attacks described them as devastating, but businesslike. The attacks were deadly but didn't carry the psychological weight of the Nebelwerfer's howl. The development of the Schweers Wurfgerät 40, the heavy siege rocket launcher, represented the logical extreme of the Nebelwerfer concept. This weapon fired 28cm and 32cm rockets from simple frame launchers or wooden crates. Each 32cm rocket weighed 79 kilograms and carried an enormous 50-kilogram warhead filled with incendiary compound or 45 kilograms of high explosive in the 28cm version. The heavy rockets were devastating against fortifications but had extremely limited range. The 32cm incendiary rocket could reach only 200 meters, This meant the launchers had to be positioned dangerously close to enemy lines. The weapons were primarily used in siege operations where the short range was acceptable. At Sevastopol, during the lengthy siege of that Soviet naval fortress in 1942, German forces deployed Schwerswurfgerät 40 launchers extensively. The heavy rockets proved effective against concrete fortifications that resisted conventional artillery. The sheer weight of explosive delivered 50 kilograms per rocket could crack even reinforced concrete when multiple rockets struck the same area. The sound of the heavy rockets in flight was even more terrifying than the standard Nebelwerfer. The larger diameter and heavier construction created a deeper, more resonant howl. Soviet defenders at Sevastopol reported that the heavy rockets sounded like freight trains falling from the sky. The psychological impact was so severe that some Soviet units refused to remain in forward positions when heavy rocket attacks were anticipated, forcing Soviet commanders to rotate units frequently to prevent complete breakdown of morale. The Wolframen 40, a frame launcher that could be mounted on half-tracks, allowed German forces to bring heavy rocket fire directly into close support of armoured formations. The launcher consisted of 6 frames, each holding a single 28 cm or 32 cm rocket. The frames were mounted on the sides of Skiev's 251 half-tracks, 3 frames per side. This configuration earned the vehicle the nickname Stuka zu Fuß, Stuka on foot, comparing its shock effect to the Junkers 87 dive bomber. The Wolframen-equipped half-tracks saw extensive service on the Eastern Front, particularly in the Waffen-SS Panzer divisions. The vehicles would accompany panzer attacks, moving close to enemy positions under cover of the advancing tanks. Once in range, they would unleash their 12 heavy rockets in rapid succession, saturating enemy positions with explosives just before the panzers and infantry moved in for close assault. The shock effect was tremendous. Soviet troops who had held firm against tank attacks and conventional artillery often broke when subjected to the combined assault of Wolframen bombardment, followed immediately by armoured assault. The weight of fire delivered in such a short time period simply overwhelmed defensive formations. But the Wolframen system had significant limitations. The rockets were extraordinarily heavy and difficult to reload under combat conditions. The thin armour of the half-track offered no real protection, and the distinctive profile of the loaded launcher frames made the vehicles priority targets. Crews knew that any hit to a loaded frame would likely detonate the entire rocket, destroying the vehicle and killing everyone aboard. Despite the risks, Wolframen units were considered elite formations. The danger and the spectacular effect of their weapons gave crews a certain prestige within German armoured formations. The logistics of supporting rocket artillery units consumed resources out of proportion to the unit's size. A Nebelwerfer battery of 6 launchers required multiple trucks for ammunition transport, a workshop truck for maintenance, command and communications vehicles, and separate fuel and supply vehicles. The entire support tail for a single battery could include 20 or more vehicles, each requiring fuel, maintenance, and spare parts. Compare this to a conventional artillery battery, which required fewer support vehicles because artillery ammunition was denser and more efficiently packed. The same truck that could carry 100 conventional artillery shells might carry only 40 to 50 Nebelwerfer rockets. The volume and weight inefficiency of rocket ammunition was a permanent limitation of the system. German logistics officers in late 1944 calculated that supporting rocket artillery consumed 3 times the transport resources of equivalent conventional artillery. With Germany's fuel supplies critically short and truck transport at a premium, this inefficiency became a serious argument for reducing rocket artillery in favour of conventional guns. But frontline commanders resisted. The Nebelwerfer's psychological impact and tactical flexibility made it invaluable despite its logistics burden. Units that had Nebelwerfer support didn't want to give it up. Commanders who had seen what massed rocket fire could do to enemy morale argued forcefully for maintaining and even expanding rocket artillery forces. The debate was never resolved. Germany's collapse came before any final decision on reorganizing artillery forces. The crews who operated Nebelwerfers lived with certain knowledge of their vulnerability. They knew that every time they fired, they marked themselves for death. Allied counter-battery fire was relentless and increasingly accurate as the war progressed. Radar systems that could track shells and rockets backward along their trajectory gave Allied artillery the ability to pinpoint German firing positions within seconds of detecting a launch. This created a grim mathematics. Fire your salvo. You have 90 seconds before counter-battery shells start landing. Can you disconnect the electrical cables, limber the launcher to your tow vehicle, and drive 200 meters to cover in 90 seconds? Sometimes yes, often no. Nebelwerfer units suffered heavy casualties throughout the war. Entire batteries could be wiped out by a single well-placed Allied artillery concentration that caught them during reloading. The psychological strain on crews was immense. You performed a task that attracted instant enemy attention. Your survival depended on speed, discipline, and luck. Mostly luck. Some crews developed superstitions. They would always approach the launcher from the left side, never the right. They would tap each rocket 3 times before loading it. They would never mention specific plans for after the war, as that invited bad luck. These rituals provided psychological comfort in a situation where rational analysis offered no reassurance. The mathematics of survival were simple and brutal. Fire and displace fast enough, and you might survive. Hesitate, and you die. The final months of the war saw Nebelwerfer units fighting with increasing desperation and declining resources. Ammunition supplies that had been merely inadequate became nearly non-existent. Units that should have had hundreds of rockets in reserve might have a few dozen. Some batteries went days without firing for lack of ammunition. When they did fire, they made each rocket count, carefully selecting targets and calculating firing solutions with extra precision, because there might not be ammunition for follow-up salvos. Fuel shortages meant that the mobility essential to Nebelwerfer doctrine became impossible. Units that should have displaced after every salvo found themselves stuck in position because there was no fuel to move the tow vehicles. This turned Nebelwerfer operations into suicide missions. Crews would fire their salvos knowing they couldn't displace, knowing counter-battery fire was coming, but firing anyway because those were their orders, and because their rockets might help slow the Allied advance by minutes or hours. Personnel replacements stopped arriving. Veteran crews that suffered casualties in early 1945 weren't reinforced. Batteries that should have had crews for 6 launchers might have enough men to operate 3. They fired with partial crews, with men performing multiple roles, with standards of safety and procedure abandoned in the face of necessity. Some batteries combined their surviving personnel and equipment, merging 2 or 3 depleted batteries into a single functional unit. Others fought until they had insufficient crew to operate even a single launcher, then destroyed their equipment and joined infantry units for the final battles. The Nebelwerfer units that fought in the defense of Berlin in April 1945 were shadows of the powerful brigades that had terrorized Soviet troops in 1941. They operated with captured ammunition, mismatched equipment, and composite crews thrown together from survivors of destroyed units. They fired until their ammunition was exhausted, then abandoned the launchers and fought as infantry. Some crews refused to abandon their weapons, instead destroying the launchers with demolition charges to prevent capture. A few crew commanders reported firing their final salvos directly at advancing Soviet tanks from point-blank range, a desperate and futile gesture that achieved nothing, except perhaps a small measure of defiance. In the Nebelwerfer's final actions, the weapon came full circle. It had begun the war as a sophisticated artillery system operated by trained specialists. It ended the war as a desperation weapon fired by exhausted survivors who knew they were fighting for a lost cause. The sound that had once struck terror into enemy forces became a death rattle, the last howl of a dying regime. The technical legacy of the Nebelwerfer extended far beyond World War II. The principles refined in the weapon's design informed rocket artillery development for decades. The understanding that spin stabilization could produce acceptable accuracy without complex guidance systems influenced Cold War-era rocket design. The tactical doctrine of massed fire from dispersed launchers, followed by rapid displacement, became standard practice in modern rocket artillery operations. Soviet post-war rocket systems clearly showed German influence. The BM-14, introduced in the 1950s, used spin-stabilized rockets similar to the Nebelwerfer's design. The Soviets had learned from both their own Katyusha experience and from captured German equipment. The synthesis produced rocket artillery systems that dominated Soviet doctrine for decades. China, receiving Soviet technical assistance in the 1950s, developed their own rocket artillery based on Soviet designs that incorporated German-derived features. North Vietnam used these systems extensively during the Vietnam War. American forces in Vietnam encountered rocket artillery that traced its conceptual lineage back to the Nebelwerfer, though the weapons themselves were generations removed from the original German design. The psychological dimension of rocket artillery, the understanding that sound and spectacle could be as important as destructive effect, became a recognized element of modern weapons design. Soviet doctrine explicitly addressed the morale effects of massed rocket fire. Training materials discussed the importance of concentrating fire for maximum psychological impact, not just physical destruction. This understanding came directly from observing the Nebelwerfer's effectiveness in World War II. Modern militaries still struggle with the same trade-offs that limited the Nebelwerfer. Rockets remain less accurate than conventional artillery, though GPS guidance has dramatically improved precision for modern systems. Rocket ammunition remains bulky and inefficient to transport compared to artillery shells. The logistics burden of supporting rocket artillery is still higher than supporting equivalent gun artillery, but the advantages remain compelling. Rocket artillery can deliver massed fire more quickly than gun artillery. It requires simpler, lighter launchers that are easier to conceal and transport. The shock effect of multiple rockets impacting in rapid succession continues to provide tactical and psychological advantages. These trade-offs, first explored systematically by German engineers developing the Nebelwerfer, still define rocket artillery doctrine today. The survivors of Nebelwerfer attacks carried the memory for life. Veterans organizations in multiple countries have documented accounts from soldiers who experienced screaming Mimi or moaning Mini attacks. The consistency of these accounts across different nationalities and different theatres of war speaks to the weapon's profound psychological impact. Nearly every account mentions the sound first. The distinctive howl dominates memories more than the explosions themselves. Veterans describe lying in foxholes or trenches, hearing that moan beginning in the distance, building to a crescendo, knowing that death was approaching at several hundred meters per second, and being powerless to do anything except press themselves against the earth and pray. Many veterans reported that conventional artillery bombardment, while dangerous, became almost routine after extended exposure. You learned to judge the incoming rounds, to estimate where they would land, to know when you were in danger and when the shells were landing elsewhere. But Nebelwerfer fire never became routine. The sound remained alien and terrifying no matter how many times you heard it. Each attack felt like the first time, producing the same visceral fear response. Psychologists studying combat stress in World War II, veterans identified Nebelwerfer survivors as a distinct cohort with particular trauma patterns. The auditory trauma, specifically, produced lasting effects. Many veterans developed sound sensitivities, becoming anxious or experiencing flashbacks when exposed to sounds that resembled the Nebelwerfer's howl. Air raid sirens were common triggers. Some veterans couldn't tolerate being near airports because jet engines spooling up produced harmonic frequencies similar to the rocket's sound. One documented case involved a British veteran who could not attend his granddaughter's orchestra concerts because the sound of warming up strings instruments, that discordant rising and falling of multiple notes, too closely resembled the memory of incoming rockets. He would begin shaking and sweating. His heart rate would spike. He would have to leave. This was 40 years after the war. The sound had left permanent marks on his nervous system. The German crews who operated Nebelwerfers rarely discussed the psychological impact their weapon had on enemy troops. Post-war interviews with former crew members show a certain disconnect. They remembered the technical aspects of the weapon, the procedures, the tactics, the constant danger from counter-battery fire. When asked about the sound and its effect on enemies, most responded with variations of, "We never thought about that," or "We were too focused on our own survival to consider what they were experiencing." A few veterans expressed something like remorse, though always carefully qualified. One former battery commander, interviewed in the 1980s, said, "We knew the weapon was effective. We heard reports from intelligence about prisoners being terrified of it, but in the moment you don't think about that. You're calculating firing solutions, watching for counter-battery, trying to keep your men alive. The enemy is abstract. After the war, when you have time to think, you realize what it must have been like. The sound was unintentional, an accident of engineering, but we used it anyway. We knew what it did to men. We fired the rockets anyway. What else could we do? We were soldiers. That was our weapon." This ambivalence, The recognition of what the weapon did combined with the pragmatic acknowledgement that soldiers use the weapons they're given appears frequently in veteran accounts from all sides. Men who operated Nebelwerfers understood in retrospect that they had wielded a weapon of terror, but understanding came later, if at all. In the moment, they were simply doing their jobs. The preservation of Nebelwerfer launchers in museums worldwide speaks to the weapon's historical significance. These artifacts serve as tangible connections to a conflict that grows more distant with each passing year. The last World War II veterans are dying. Soon there will be no living memory of what that sound meant, of the terror it inspired, of the impact it had on men's minds and bodies. The preserved launchers are silent now. They sit behind velvet ropes or in glass cases. They don't howl, they don't fire, they're just metal tubes and wooden wheels, interesting relics of mid-20th century military technology. But for the diminishing number of veterans who stop in front of those displays, the launchers aren't silent at all. The sound lives in memory, as fresh and terrible as it was 80 years ago. The Nebelwerfer's place in military history is secure. It was not the most important weapon of World War II, not the most destructive, not the most technologically advanced, but it was among the most psychologically effective weapons ever deployed. It achieved its effects through an accidental byproduct of engineering, the howl created by angled exhaust vents designed for spin stabilization, not terror. Yet once German commanders recognized the psychological power of that sound, they exploited it ruthlessly. The Nebelwerfer became more than a rocket launcher. It became an instrument of psychological warfare, a tool for breaking enemy morale, a weapon that attacked the mind as aggressively as the body. The sound of the screaming Mimi, the howl of moaning Minnie, became part of the soundtrack of World War II, as iconic as air raid sirens or anti-aircraft fire. For men who heard it, the sound never faded. It lived in nightmares and flashbacks, in sudden, startled reactions to innocent sounds, in the way veterans' hands would shake when asked to remember. The battlefield is never silent. Artillery roars, machine guns rattle, tanks rumble, aircraft scream overhead, soldiers shout, the wounded cry out. But among all the sounds of war, few achieved the psychological impact of the Nebelwerfer's howl. It was the sound of approaching death, undeniable and inescapable. It was the sound of terror made audible. It was the scream of war itself,